Hello there, Narek is here. Today I'm going to talk about the unit circle or the trigonometric circle. So previously I did an introduction to trigonometry, but in this video we're going to continue. We're going to talk about the unit circle. What do we mean by the trigonometric or unit circle? Plus we're going to take a few examples about some angles. How are we supposed to find the endpoints? How are we able to position these angles on the unit circle? So let's first start by defining and talking about this circle, the unit circle. So it's a circle which is defined in the Cartesian plane, x prime or x, y prime or y. It has several characteristics. The first characteristic that you should be talking about is that the radius of this circle is actually 1. The radius is 1 unit. This is the first characteristic. The second characteristic is that we have a positive orientation. We have a positive orientation which is counterclockwise. So whenever I'm going to position a certain point which has a certain angle, of course, I have to check if the angle is positive, so I will have to go counterclockwise. If it's negative value, I will have to go clockwise. So the positive orientation is simply counterclockwise. Third characteristic, we can mention that this point, which is called A, is actually called the origin. O is simply the center, and this circle is divided into 4 quadrants. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Of course, each quadrant has its own characteristics. I'm going to talk about it, of course, after defining this circle. So, radius 1 unit, the origin A, positive orientation, which is counterclockwise, and the 4 quadrants. Now, let's take an example of a certain angle. Let's call this angle alpha. How are we supposed to position this point M, which has an angle 30 degrees? You start from point A, you have to open a certain angle which is 30 degrees. At this position you will have the point A and the point M. So from the angle between OM and OA is simply 30 degrees. You get 30 degrees and you have to use the conventional orientation simply because your angle is plus 30 degrees. Now let's say it was an angle of minus, I'm going to take the example beta is equal to minus 45 degrees, and this is the point N, let's say. Since it's minus 45, so you will have to go clockwise, so it will be the opposite orientation of the conventional direction. This is how you will have the angle beta, which is minus 45 degrees, and this will be the position of your point N. So with the unit circle, or simply the trigonometric circle, we can have angles which could be positive, negative, 0. Whenever we had the right triangle, we had angles which were simply positive. In this case, you can have values which are negative. So negative, it means that you have to go clockwise, which is of course the opposite direction of your conventional positive orientation. Another important question here: is alpha, which is 30 degrees, the only angle that gives me the position for point M? Of course not. Let's say I will have to take an angle, I'm going to call it alpha prime, which is equal to 390 degrees. Now 390 degrees is actually the sum of 360 degrees plus 30 degrees. 360 degrees is the whole revolution. So I'm starting from point A, I'm reaching to point A. This is how I did the whole revolution of 360 degrees. And then from point A, I'm having an angle of 30 degrees. Of course, it's going to get me to the point M. So whenever you're doing a full revolution, it could be one full revolution, two full revolutions, three, it depends. You're going to get to the same point. So 360 plus 30 degrees, it's simply the same thing as 30 degrees, and it's going to get me to the point M. What about the angle, for example, alpha double prime, which is equal to minus 330 degrees? Minus 330 degrees, it's simply minus 360 degrees plus 30 degrees. So again, I did a revolution, full revolution, but in the opposite orientation. Of course, I'm starting from point A, a full revolution, but clockwise. I will reach to the point M, and from point A, I will have to do plus 30 degrees, so I will get back to the point M. So the angle which was 30 degrees, it's not simply the only and unique angle which will give me the position for point M. I can have full revolutions in the positive side and negative side and still get to the same endpoint. Of course, it's the same thing for whether the angle is negative, just like beta minus 45. Now, whenever you have a certain angle which is higher than let's say 180 or higher than 360, you can find, I'm going to talk about also in this video or in another video, how are we supposed to find the principal value. How are we supposed to find the principal value of this angle? It's going to be another video. I'm going to talk about in another video about radian, degree, plus the principal value of each arc whenever the angle is greater than 180 or smaller than minus 180. All right. So that's the first part of the first part about the unit circle. The second part is to talk about the unit circle, but we're interested about the coordinates of a certain point which belongs to this circle. So let's take again the same example. This is our circle. The radius is 1. This is the positive conventional orientation. This point, it's simply the origin A. In case you want to talk about the center, it's O. And I'm going to choose a certain point which is called M, and such that OM, the segment OM, makes a certain angle alpha with the axis of abscissa. Can we talk about the trigonometric functions? Of course. But first, let's talk about the coordinates of point M. The point M has the coordinates A, B. What about A? What about B? In order to find A, you simply have to check its position on the axis of abscissa. So this part represents A, and I'm going to call it the segment OH. And as for the ordinate, you will have to check on the axis of ordinate. It will be this segment, which is B. I'm going to call this point J. So M is defined by its coordinates A and B. Can we define it by using trigonometric functions? Of course. So what about the first one, cosine alpha? What about cosine alpha? Cosine alpha, it's adjacent over opposite. Adjacent, it's OH over OM. What do we know about OM? OM is simply the radius, which is 1 unit, since it's the unit circle. So it will be OH. OH, it represents A. So cosine actually is the abscissa of the angle that intersects with the circle. So it's simply the abscissa. It's directly linked with the abscissa of the point that intersects with your circle having the angle A, alpha. What about sine of alpha? Sine alpha, it's opposite over, sorry, in this case I made a small mistake. So it's adjacent over hypotenuse. Sine alpha, it's opposite over hypotenuse. Opposite, it's MH over OM again. What about MH? MH is the same thing as OJ. OM is 1 again. What about OJ? It's simply B. So sine alpha, the sine of a certain angle, is directly linked with the ordinate of the point M, which represents, of course, the intersection with the angle for the angle alpha that I have. In case you want to calculate tangent alpha, it's simply sine alpha over cosine alpha, so it will be B over A, and this is how you calculate tangent alpha. So your point M, which had the ordinates A and B, we can say that M, it has the coordinates A and B, it has the coordinates cosine alpha and sine alpha. It will be defined by these trigonometric functions. Now, what about a certain point? Let's call this point K, which belongs to this position, and the angle in this case is gamma. Now if you check the position of K, it's no more in the first quadrant. K has a certain abscissa which is negative, so it will have a certain abscissa. I'm going to call it X. X is negative. As for Y, the ordinate, I'm going to call it Y, it's positive. So K actually belongs to the second quadrant, where the abscissa is negative, the ordinate is positive. So automatically your trigonometric function cosine will be negative and sine will be positive. And you can conclude tangent will be negative. These are the things that are very important in the unit circle. You have to know your point belongs to which quadrant, and from the quadrant you will be able to find out if your cosine is negative, your sine is negative. So I'm gonna take again the unit circle. I'm gonna talk about the unit circle, and we're gonna talk about the trigonometric functions related to its position regarding the quadrants. So what do we know about the first quadrant? In the first quadrant, the abscissa is positive, the ordinate is positive, so automatically you will have cosine positive, sine positive, so tangent positive, cotangent positive. What about the second quadrant? In the second quadrant, the abscissa is negative, the ordinate is positive, so cosine will be negative, sine will be positive, and tangent will be negative. Of course, cotangent will be also negative. What about the third quadrant? In the third quadrant, if you pay attention, you have cosine negative, sine also negative, because the abscissa is negative and the ordinate is negative. So you can simply say that cosine is negative, sine is negative. So your tangent and cotangent will be positive. And finally, the fourth quadrant. In the fourth quadrant, you have cosine, which is positive, but sine negative, because your axis of abscissa is positive and your axis of ordinate is negative. So you will have cosine positive, sine negative, so your tangent and cotangent will be negative. So you don't have to memorize about the sine or the angle of each trigonometric function. You simply have to know the position of your point M, or whatever point it is, the moving point. Once you know it belongs to which quadrant, you will simply conclude about the cosine, the sine of cosine, the sine of sine, and plus, of course, tangent, cotangent. So this is a very important thing about the trigonometric circle or the unit circle. What about taking a few examples related to trigonometric function where we're gonna position a few angles, the endpoints of a few angles? So let's take a few examples. We have our trigonometric function, a trigonometric circle. All right. Now we have to position a few points. Let's start. The first one is the point M, which has which of course is related to the angle alpha is equal to 200 degrees. Now 200 degrees, it represents 180 plus 20. 180, it's half revolution plus 20 degrees. So it's a position which is very close to this point. So your point M will have this position. This is 200 degrees. Now, let's say someone would choose, instead of 200 degrees, alpha prime is equal to minus 160 degrees. Minus 160 degrees is minus 180 degrees plus 20 degrees. So you will reach to the same point M. Why? Because you're doing a half revolution in the negative orientation, and then plus 20 in the positive orientation, you will reach to the same point M. So minus 160 or 200 degrees, they have the same end point, which is the point M. So in this case, it's also the point M. I'm going to take another example. Let's say alpha 1 is equal to minus 70 degrees. You will have to choose the orientation which is the opposite of the positive conventional orientation. It will be in this direction. So minus 70 degrees, it's simply somewhere here. I'm going to call this point N. So this is the position of the point N. What about a certain angle, a certain point, alpha 2, and this is for the point, let's say J. Alpha 2 is 135 degrees. 135 degrees. You will have to go from this point and make an angle of 135 degrees. So it's a point which has this position. If we're going to talk about each point and to which quadrant it belongs, the point M, for example, it belongs to the third quadrant, where cosine is negative, sine is negative, tangent is positive, cotangent is positive. So whenever you want to check with your calculator cosine of 200 degrees, you will get a negative value. Sine of 200 degrees, you're going to get a negative value. As for tangent to 100 degrees, you're going to get a positive value. The point N, for example, which belongs to the fourth quadrant, it's sine, which is negative, cosine is positive, tangent is negative, cotangent is negative. The point J, which is for the angle alpha to 135 degrees, it belongs to the second quadrant where cosine is negative. So whenever you're calculating, let's say, cosine of 135 degrees, you're gonna get minus 1 over radical 2, square root of 2, which is minus 0.7, etc. So this is how you're gonna get a negative value, simply because it's an angle, obtuse angle. It belongs to the second quadrant where cosine is negative. So knowing each point it belongs to which quadrant, it will help you to find about the sign of your trigonometric function, whether your cosine, sine, or tangent or cotangent are negative, positive, about the sign. So that's it for the unit circle. In the next video, I'm going to talk about the angle, the unit angle radians. How are we supposed to convert from degree to radians, from radians to degree, plus how are we supposed to find the principal value of any arc. So that's going to be in another video, in the next video. That's all for today. Don't forget to subscribe to my channel. You'll be notified whenever I upload the next video or the new video or any new material. I can also share with you my Instagram, Facebook account in case you want to contact me, or if you have any other question, you can leave a comment below. Thank you for watching. I hope it was helpful, and see you next time.